Welcome back. The division algorithm. If a and b are integers with a non-zero, we say that a divides b if there is an integer c such that b equals a times c. You see, or equivalently, b over a is an integer, right? A divides b if a is a factor, that is, a multiplies something to get you b. So a is a factor of b. When a divides b, we say that a is a factor or a divisor of b, and that b is a multiple of a. The notation a vertical slash b, it's used to denote that a divides b. We write a vertical slash crossed out b when a does not divide b. That is, a divides b if there exists c such that a times c is b. You understand? All of this means a is a factor of b. A is a divisor of b. There exists an integer c such that a times c is b. They all mean the same thing. Let n and d be positive integers. How many positive integers not exceeding n are divisible by d? What does that even mean? Let's take two integers, n and d be integers, right? So suppose you have n equals, I don't know, 31 and d equals 4. How many positive integers not exceeding n, that is, you're not allowed to cross 31, are divisible by d, right? Integers, positive integers, right? How many positive integers? So positive integers not exceeding 31 divisible by 4 are, well, who is divisible by 4? 4 is divisible by 4. 8 is divisible by 4. 12 is divisible by 4. 16, 20, 24, 28. The next one is going to be 32, but we are not allowed to exceed 31. So that's it. So how many did we get? 1, 2, 3, 4, 5, 6, 7. So there are 7 positive integers not exceeding 31 divisible by 4. Is there an easier way of seeing this? Yes, indeed. Why not divide 31 by 4? When we divide 31 by 4, the quotient is 7 and the remainder is, so 3. You see, 4 times 7 is 28 and then 3 left over. In other words, what happens? You divide 31 by 4 if you like, right? You take the fraction 31 over 4. If you actually divide it, you will get 7 point something. So you are going to take the floor of 31 over 4. And that is 7. You understand? So the question is here, let n and d be integers. So n was 31, remember? D was 4. This is just an example. How many positive integers? So number of positive integers not exceeding n which are divisible by d is the floor of the fraction n over d. That's what it is. All right. Continuing. Let where did my lecture go? There you go. Continuing, let A, B, C be integers where A is non-zero, so A is the divisor. Then A divides B. If A divides B and A divides C, then A divides B plus C. This is easy to see, okay guys? Look, first part. If A divides B, then A times some number is B. If A divides B and A divides C. If A divides C, then A times some possibly another number is C. You see? Therefore, A times N plus A times M equals B plus C. What does that even mean? That means A times N plus M equals B plus C. You see, all I did was took out A common. In other words, A times some number is B plus E. Therefore, B plus C. A divides B plus C. You see, A is a factor of B plus C. That's all they are saying. If A divides B, A divides C, then A has to divide B plus C. In the same way, the second one is quite similar, in fact straightforward. If A divides B, then there is a number n such that A times n equals B. Well, what are they saying? If A divides B, then A has to divide B times C for all integers C. Well, of course it does. A times n is B, therefore A times n times C is B times C. In other words, A times NC is BC, you see. In other words, A is a factor of BC. That's what it means to say. And this happens for every C integer C. Alright. A is a factor of BC. Hence, A divides BC for all integers C. Okay, that was the second one. Next, if A divides B and B divides C, what does that mean? A times some number is B. B divides C, B times some number is C. All right. So let's figure this out. A times some number is B. B times some possibly other number is C. Hence, where I see B, I'll replace it by A times N. You see, that is A times NM is C. What does this mean? This means A divides C. That's all. Okay. Here is an important corollary. If A, B, C are integers such that where A is non-zero, that's my divisor. A divides B, A divides C, then A divides MB plus NC. They are saying it's a corollary. Why? Well, if A divides B, then by 2, A divides B times any multiple. Okay? So, corollary 1, we are given that A divides B. So, A divides MB for any integer M by proof of 2. You see, by here. All right. Likewise, A divides C to A divides N times C. Similarly, A divides C, so A divides N times C for any integer N. Well, now what do we know by 1? By proof of 1, what do we know? A divides this guy, A divides this guy, A divides their sum, MB plus NC. Right? If A divides two integers, then A has to divide their sum. That's all we are saying. Alright, so that was a corollary. We'll come to division algorithm in the next video.